Welcome to STEMSIMS. STEMSIMS is a suite of over 120 interactive contextual simulations designed for grades 3 through 12 students to help them deeply explore STEM topics. The development of STEMSIMS was supported by the National Science Foundation, the National Institutes of Health, and the Department of Homeland Security. STEMSIMS are more than just simulations. Each simulation is housed in a module with a variety of content support. Content experts created over 700 student-ready lesson plans, over 1,000 assessment items, video tutorials to support each simulation, and other materials designed to enhance student learning. A teacher guide provides answers to all assessment items and teacher tips for using STEMSIMS. All of these materials have been rigorously field tested. The design team of STEMSIMS focused on addressing the NGSS standards, in particular the need for learning tools that support the engineering design practices specified in the NGSS. In fact, almost one-half of STEMSIMS modules address these critical engineering practices. For instance, in the Directorate simulation, students design, create, and test quadcopter models. Instead of merely replicating traditional laboratories, STEMSIMS focused on providing students with experiences that were hard, if not impossible, to replicate in the classroom. Because of team developers' relationship with the University Centers of Excellence from around the country, many of these experiences feature cutting-edge investigations. For instance, in the beta voltaics module, students compare and contrast traditional and nuclear batteries for applications such as the use in heart pacemaker devices. In the energy downer module, students investigate elevators that at certain times of the day generate more electricity than they consume. As you can see, these are not your typical laboratory experiences. STEMSIMS mathematics modules and applications are not drill and kill. Instead, mathematics is experienced in context. For instance, in the fueling station simulation, students use perpendicular bisectors to find ideal location of a new fueling station that least impacts the 3 or 4 existing fueling stations. All of the modules were designed using an inquiry-based learning approach. Since the environment is virtual, students are free to create their own methodologies in a safe setting. Although STEMSIMS offers a variety of lesson support, teachers and students have the option of using the materials or conducting pure inquiry-based investigations. STEMSIMS can be used by students individually or as group projects. For instance, in the water rocket simulation, if a teacher chooses, each group of students could investigate one aspect of rocket flight. One group could focus on flight angle, another on fluid volume, and so on. The groups can then share their data and as a class decide on the best rocket design. An important note, most STEMSIMS are designed with dynamic data, which means that two students working at the same time on the same simulation will have slightly different data. This reduces the likelihood of all students copying one student's data. In some STEMSIMS modules, economic factors associated with engineering designs are investigated. For instance, in the erosion control simulations, after students investigate erosion using a water stream, students have to then select erosion control methods to protect a school's basketball court from a potential landslide. The cost of each erosion control method must be factored into their final design. Students experience the trade-off between the best design and real-world cost factors. STEMSIMS uses the power of technology to address a variety of student learning styles. For instance, in the chemical mixer, students study writing chemical formulas using color and sound as cues to help create molecular formulas using the correct elements in the appropriate proportions. Research suggests the more senses used to experience learning, the more likely deep understanding of the concept under investigation will take place. STEM-SIMs can also be translated into over 100 different languages by simply selecting the Google Translate option. You can search for STEM-SIM lessons by keyword, by standard, and by some textbooks. But you might ask, how effective are STEM-SIMs in helping students understand core STEM topics? Because STEM-SIMs were developed with the support of a major funding agency, they were rigorously tested with thousands of students and teachers. The use of STEM-SIMs resulted in average student achievement gains of 30% on assessments similar to those found on high-stakes tests. Teachers and student users also overwhelmingly rated STEM-SIMs as highly useful and highly interesting. Here are a few comparisons of STEM-SIMs with some other simulation-based offerings. STEM-SIMs has lots of engineering projects. They're beyond simple replication labs, really easy to use controls, and their lessons were created by experts. STEM-SIMs encourages group collaboration. It provides teacher guides with answers and teaching tips, and content background and video guides are supplied. STEM-SIMs also are challenge-based, offer high-quality graphics, engagement brochures and activities, and are standards-based. We hope you enjoyed this brief presentation on STEM-SIMs. Please feel free to contact us for more information and for purchasing discounts in our professional development offerings at stemsims.com.